Hi there, and welcome to this lesson on Pure Mathematics 3. And in this lesson, we're looking at the quotient rule. Now, the quotient rule enables you to differentiate two functions that are being divided. So, for instance, if y was equal to u divided by v, where u is a function of x and v is also a function of x, the first thing we could do is rewrite that as a product. So that means the same thing as y equals u times by v to the power of minus 1. And we can differentiate this using the product rule in order to derive the quotient rule. It's a little bit confusing because both of these are functions of x. But we use the product rule in the normal way. So we'll write down the u, differentiate v to the minus 1, write down the v to the minus 1 and differentiate the u. So writing down u is that. Differentiating v to the minus 1 gives us minus 1 times by v to the power of minus 2. And then using the chain rule, we need to remember to differentiate v itself. So that gives us times by dv by dx. And then writing down v to the minus 1 is that, and differentiating the u is just du by dx. That is the differentiation done. We just need to tidy this up a little. First of all, that would tidy to give us this. Now we've got two fractions here. It helps if both of the denominators are the same. So this second fraction here, I'll multiply the top by v and the bottom by v, and that will give me that. The reason for doing that is I can then combine these together where v squared becomes the bottom of a larger fraction. So that simplifies to dy by dx is equal to v du by dx, writing this second term down first, take away u dv by dx, writing down the first term second, with the whole thing divided by v squared. Now that looks a little bit complicated, but in practice it's not too bad. You'll know what u is a function of x, you'll know what v is, you just need to work out everything and put it into the formula. So for example, if y was equal to 3x divided by 5x minus 2, find dy by dx. So u is the function on the top, the numerator, which is 3x. V is the function on the bottom, the denominator, 5x minus 2. You just work out all of this, put it into the formula. I'll let you have a go at doing this yourself first. Pause the video, have a go, and come back to me when you're ready. Okay, let's have a look at this. So as we said, u is 3x, v is 5x minus 2. So writing down the 5x minus 2, differentiating the 3x gives me that. Write down the 3x, differentiate the 5x minus 2 gives me that. All divided by the 5x minus 2 squared. That's it. That's the differentiation done. We tidy that up a little now. And multiplying out the brackets would give us that. And 15x take away 15x simplifies the whole thing to minus 6 divided by 5x minus 2 all squared. Okay, example 2 is a little bit more tricky. First of all, it's tricky because the functions are slightly more confusing. And also we're asked to find the stationary point of this curve, y equals log x divided by x squared. The way you find a stationary point is by finding dy by dx and then saying, when does dy by dx equal 0? When does the gradient equal 0? So that'll give you an equation that you have to solve. When you've solved it, you will have found the coordinates of P. Okay, I'll let you have a go at doing this yourself. Pause the video and come back to me again when you're ready. Okay, so u is log x, v is x squared. When I differentiate that, I write down the x squared. Differentiating the log x gives me 1 over x. Take away, write down the log x. Differentiate the x squared gives me 2x. And all of that needs to be divided by the denominator squared, x squared, all squared. That's the differentiation done. Tidying that up would give me x minus 2x log x, all divided by x to the 4. I can divide through the top and the bottom by x, and that will simplify to 1 minus 2 log x, all divided by x cubed. That is dy by dx. To find the stationary point, we need to say, when does this equal 0? When does dy by dx equal 0? So we need to solve, when does 1 minus 2 log x divided by x cubed equal 0? That can immediately simplify by doing 0 times x cubed is 0, which gives us 1 minus 2 log x must equal 0. Okay, that's what we need to solve. Moving the 2 log x over to the right-hand side and dividing by the 2 will give me log x is equal to 1/2. If ever you have to solve an equation with logs, you use powers. Now this is ln. So we do e to the power of both sides. E to the power of log x equals e to the power of 1/2. And the reason why we do that is e to the power of log x, the e and log are inverse functions, so they cancel each other out. And e to the power of log x just simplifies to x. And on the right-hand side, we have e to the power of 1/2. That is the x-coordinate of the stationary point. To find the y-coordinate, we need to substitute x into the original equation. So log x over x squared, that means y will equal log of e to the 1/2 divided by e to the 1/2 squared. Now log of e to the 1/2, as before, log and e are inverse functions. That means they cancel each other out. The top will just become 1/2. E to the 1/2 squared is e to the 1/2 times by 2, using the law for powers. So the top simplifies to 1/2, and the bottom just simplifies to e to the power of 1, or just e. Now we know both x and y, so we can write down the coordinates of the stationary point P, which will be e to the power of 1/2, the x-coordinate, and 1/2 divided by e simplifies to 1 divided by 2e. Okay, example 3. Prove that if y equals the tangent of x, that if I differentiate that, I'll get sec squared x. Now that's a really important differential. It's one that you will have to learn. And the way we prove it is by writing tan x as a quotient. Tan x is equal to sine x divided by cos x. And we use the quotient rule in order to differentiate this. So u will equal sine x, v will equal cos x. I'll let you have a go at differentiating that yourself. So have a go, pause the video, come back to me when you're ready. Okay, let's have a look. So as we said, if y equals tan x, that means y equals sine x over cos x, and then we just treat that as a quotient in the normal way. So dy by dx, we'll write down the cos x, differentiate sine x, write down the sine x, differentiate the cos x, which gives us minus sine x, all divided by the denominator squared, which gives us cos x all squared on the bottom. Now, tidying up the top gives us cos squared x minus sine x times minus sine x gives us plus sine squared x, and on the bottom we've got cos squared. Well, sine squared plus cos squared equals 1, so the top will simplify to just 1. 1 divided by cos squared, well, 1 over cos is sec, 1 divided by cos squared is sec squared. So that takes us straight to the answer. Okay, that is the end of the lesson. If you've got the textbook, then turn to page 135 and have a go at exercise 6E. Thank you very much for listening, and cheerio.